Hello guys, now we'll be talking about matrices. Okay. Now when we have matrix, what do we mean? I think about a movie that I think I watched quite a long time ago. Matrix, a set of codes written in zeros and ones. Okay, and it's a really good movie. You can search online and watch it. Well, today we'll be talking about matrix. A matrix is like an array is simply like an array of numbers. Okay, it can be real, it can also be complex numbers, and that can be arranged in rows and it can be arranged in columns. Okay, so that means we have my matrix, we have whole number and it also have column number. So it's always written in rectangular array. Okay, always written in rectangular array. So we can have matrix of A11, A12, A13, A21, A22, A23, A31, A32, A33. Now we realize that our first number, okay, if we look at everyone and expand on it, we have A11. Realize that the first number is our row number, and the second number is our column number. Okay, so we have that A11. Okay, so we need to try and expand the matrix. So realize that A11 is in row 1, okay, column 1, and definitely A31 will be in row 3, but in column 3. Okay, so and A33 will be in row 3 and column 3. Okay, so in short, we can represent the row. These are the rows, okay, and these will be the columns. Okay, columns are represented in blue and the rows represented in red. Okay, so it is our understanding of where the rows are located, of where the columns are also located, are very much important. Okay, so a O matrix can be denoted by a single general element embraced in brackets. Okay, and so since we have said that a matrix is simply an array of numbers and there is no arithmetic connection between the elements. Okay, so now let's look at how do we know the array in which the matrix is. So let's take, for instance, we have 5 7 5 7 2 6 3 8. Now we want to know how many rows are here and how many columns are here. Okay, so and since the rows are represented in red, okay, and the columns are represented in blue, 1 2 3, so that means we have 3 columns and 2 rows. Okay, now the array representation, the matrix representation, is always in the order of m by n. Okay, where m is the number of rows and n is the number of columns. Okay, so in this case we are saying that this matrix is in the order. Okay, so we are saying the matrix 5 7 2 and 6 3 8 is the order of 2 by 3. Okay, because it has 2 rows and it has 3 columns. Okay, so it is very important. Now if we look at another matrix, let's say 6 4 0 1 and 2 3, we'll notice that we have 1 2 3 rows. Okay, 3 rows and 1 2, and we have 2, okay, 2 columns. So in that sense we have that the order of matrix is 3 by 2. Okay, so it has 3 rows and and 2 columns, right? So it is very, very important. So we can have a might be given a matrix, a simple matrix, right? And we have to know the order of the matrix. Okay, we have to know the order of the matrix. So let's take, for instance, we have a question. Okay, let's say we have assume we're given a question: 6 5 6 minus 5 1 minus 3 2 minus 4 8 3 4 minus 7 minus 6 and 5 minus 2 9 7 minus 1. Now the first question is what is the order? You might be asked this question: what is the order of the matrix? And or the ask us what is the element, okay, of A24. Okay, that means the elements of the second row and the fourth column. Okay, and what is the element of A42? Okay, now let's start with the first one. What is the order of the matrix? Now if we count how many rows, we have 1 2 3 and 4, so it has 4 rows. Okay, and how many columns does it have? So we can count 1 2 3 and 4. Okay, so this one has what? 4 columns. So definitely the order of the matrix, okay, the matrix order is 4 rows multiplied by 4 columns. So it's another 4 by 4 matrix. Okay, it's a 4 by 4 matrix. Now what is the element of A24? Okay, that means we are going to the second row. Okay, now if we are talking about A24 elements, that means we are talking about the second row. Okay, and second row, fourth column, second row and fourth column. So if you look at this, we trace it well. So this is the second row, right, and this is the fourth column. 1 2 3 4. This is the fourth column. Okay, so where these two values, where they intersect, will be our answer. So we have this and we have this. So our answer for the element of A24 is 3. Okay, so the answer is 3. Answer is 3. And if we talk about the third question, let's call this one another property. 1 2 3, and we're talking about A42. That means we're saying A42 means the fourth row, okay, and the second column. The fourth row and the second column. Now with that done, we look at the fourth row. This, okay, this is the fourth row and this is the second column. Now if we trace it like we've done, so we are going from the fourth row and we are going into the second column, so they are intersecting here. So that means our answer is 9. Okay, so with our basic understanding of the matrix notation, right, it will help us a lot, especially when we come to addition, subtraction, multiplication, and a lot. Okay, especially when we come to complex computation of matrix. The understanding of how we can pinpoint what row number is this, what column number is this, or what's the order of the matrix. If the order of matrix is this, can I apply this operation on it? If not, then what next? So we want to quickly look at the types of matrix. Okay, types of matrix. The first matrix we'll be considering, okay, will be the row matrix. row matrix. Now the row matrix is in such a way that it has only one row. Okay, only one row, right? So that means it has just maybe two numbers, 0 1. It can also be three numbers, 0 4 3, and it can be four numbers. Okay, let's say 4 3 7 2. Okay, so that means it's only one row, but it's not limited to one column. Okay, so the order of this matrix, okay, is, we can see that it has one row, okay, and two columns here. Okay, and this one has one row also, and it has three columns. Okay, two columns, three columns, and this one has four columns, right? Four columns. Now in that scenario, we have it that this order, since we always write the order of matrix to be m by n, where m is the row and the n is the column, right? So the first example here, the 0 1, will have it be an order of 1 by 2, because it has one row and two column, and this second one will have an order of 1 by 3, because it has one row but three columns, and the third one will have an order of 1 by 4, because it has one row and four columns. The second type or example of matrix we look at is the column matrix. The column matrix has only one column. Okay, it has only one column, so but not limited. It doesn't just have one row. It has one column, and it can have as many as possible. Okay, as many as possible rows. So let's say 0. We can also say 0 1, and we can say 0 2 7, and as well we can say 4. Okay, 4 3 7 2. Now as we can see now, everything has one column, just one column, but the number of rows can be many. For this one now, it has one row. Okay, and now we can see that this one has two rows. We can see that this one has three rows. Okay, and we can also see that this one has 1 2 3 4 rows. Okay, so the order of matrix, okay, that's what it is. The order of matrix here will be 1 by 1, because it has one row, one column, and the order of matrix here will be 2 by 1, because it has two rows and a single column. The order of matrix here, okay, will be 3 by 1. It has three rows and a single column. The number of matrix here will be 4 by 1, because it has four rows and a single column. Okay, so it is very, very important to know how many rows, to know how many columns. Okay, so so as to know which operation am I to use, which operations can this matrix ascertain, so that it will help our understanding so far. So next we'll be looking at another type of matrix, which we call the square matrix, which we'll be using very often. The square matrix. Now the square matrix is such a way that it has the number of rows, okay, is the same thing as the number of columns. Okay, so we can have 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix. Okay, so now let's take an example of 2 by 2 matrix. So let's say we have 0 1 2 3. This is a 2 by 2 matrix because it has two rows, two columns, right? And let's take another example of a 3 by 3 matrix. So let's say 0 1 2 3 4 5 6 7 8. Now this is an example of 3 by 3 matrix. Now for a 4 by 4 matrix, it will have four rows and it will have four columns. 4 5, 6, 7, 8, 9, 10, 11, 13, 14. Okay, now this is a 4 by 4 matrix. It has 4 rows, 1, 2, 3, 4, and it has 4 columns, 1, 2, 3, and 4. So this is an example of a 4 by 4 matrix. So a square matrix is essential that the number of rows is the same as the number of columns. Okay, now in the next type of matrix, we'll be looking at the diagonal matrix. Now in matrices, okay, in matrices there's something we call the leading diagonal or the following diagonal. Okay, now these diagonals come up when in a square matrix. Okay, so we can call a diagonal matrix as a square matrix with all elements 0, with all the elements 0 except those on the leading diagonal. Okay, so what do I mean by leading diagonal? Let's take, for instance, I have the 2 by 2 matrix that we had before. Now the leading diagonal often starts from the top left corner to the bottom right corner. Okay, leading matrix. Okay, that's the leading. This is the leading diagonal. Okay, now if we also take a look at this 3 by 3 matrix, the leading diagonal starts from the top left corner to the bottom left corner, so to the bottom right corner. Okay, from the top left to the bottom right, and everything intersecting that line. Okay, so we have 3 elements there. We have 0, we have 4, we have 5. Okay, those are the elements on the leading diagonal. Now if you look at the 4 by 4 matrix we have here, you will go from the top left and go to the bottom right. Okay, we realize that if we draw a connecting line between them, we will have 4 elements between them. Okay, now this is what they call the leading diagonal. Now a diagonal matrix is now such in which it is a square matrix in which all the elements are 0 except those on the leading diagonal. So the first thing we have to do is to have a square matrix. Okay, now let's just have a square matrix of, let's say, 0, 1, 2, 3. Okay, now what is the leading diagonal? What is the leading diagonal? We know that the leading diagonal is this. Okay, leading diagonal. Now are the elements on the leading diagonal, let's change them. Are they 0? No, except this. Okay, so we can change this. Let me change this to, let's say, 4. And if we remove all these values and change them to 0, this becomes a diagonal matrix, in such a sense that only the elements on the leading diagonal are greater than 0. The others are actually 0. So we can also have a leading diagonal. Let's go to a 3 by 3 matrix, or let's say 1, 0, 0, 0, 2, 0, and 0, 0, 3. Now if we look at the elements of this matrix, we realize that all the elements except those on the leading diagonal, okay, except those on the leading diagonal, are 0. So we will call this a diagonal matrix. Okay, now the next example, the next type of matrix we'll be looking at is the unit matrix. Okay, the unit matrix. Now the unit matrix is such a way that it has the unit in its sense. Unit is in sense is it's denoted by 1. Okay, the unit of a number is 1. Okay, so if you say 1 unit, that means you're saying something is representing 1. Okay, so it's like a diagonal matrix in which the elements on the leading diagonal are all unity. Okay, so let's just say that the elements, okay, elements on of the diagonal matrix, okay, are 1. Right, so or we'll say the element on the of the leading, okay, the elements on the leading diagonal of a diagonal matrix are 1. Okay, so let's look at this example where we have 1 0 0 0 2 0 0 0 3. Okay, we all agree that this is a diagonal matrix. Now instead of having 2 and 3, make them just 1 1. Okay, now this is a unit matrix, and it can also be a 2 by 2 matrix where we'll have 0 1 or 1 0 and 0 1. This is also a unit matrix. It can also be 4 by 4, and it can also be 5 by 5. And the last example, the last type of matrix we will be considering, okay, the last type of matrix we will be considering is the null matrix. Null matrix. Now when you say something is null, okay, that means we are saying that all elements are 0. Okay, all elements are 0. So that means we are saying whether it is a square matrix or a diagonal matrix or a unit matrix, all the elements are 0. So that means we have 0 0 0 0, or it can also be 0 0 0 0 0 0. Okay, and it can also be all zeros, in which all the elements are 0. So therefore we can say that the product of a null matrix with another matrix is 0, but we are yet to come to product of matrices. So in our next video we will be talking about addition and subtraction of matrix, including multiplication of matrices. Okay, including multiplication of matrices. So let's take a quick recap on this video. So we understand that matrix in its sense are elements denoted in a rectangular array, okay, where we have rows and we have columns. So a matrix is composed of rows and also columns, in which there is no necessarily an interconnection between the individual row or the individual columns. Now we have our order of matrix to be written as m by n, where m is the number of rows and n is the number of columns. Now we can see here that we have 3 rows and we have 2 columns, so we write it as the order as 3 by 2. Okay, and with the matrix notation that we have here as A11, A12, A13, A21, A22, A23, A31, A22, A32, and A33, we can be easy to note out, find the elements. Okay, find the element. This is often known as the double suffix notation. Okay, double suffix notation of a matrix. So with that, you can find a particular element given a row number and a column number, which is what we did here. Now we talked about the types of matrix. Okay, there are various types of matrix, but we are limiting it to 5 or 6. The row matrix in such a way that there is just only one row, and the columns, okay, the columns can be more than one, and the column matrix is such a way that there is only one column, but the rows, okay, definitely can be more than one. The square matrix is such that the number of rows of the matrix are equal to the number of columns. Okay, so that's why we're having 2 by 2 matrix, or 3 by 3 matrix, or 4 by 4 matrix. Okay, and we'll have diagonal matrix. This is a matrix that the is a square matrix in which all the elements except those on the leading diagonals are zeros. Okay, and we have unit matrix in which all the elements on the leading diagonal of a diagonal matrix are 1, because they are all unity. And the null matrix is that in which all the elements are 0. So in our next video, we'll be talking about addition, subtraction, and multiplication of matrix. Addition, subtraction, and multiplication of matrix.